Okay, today it's a review for the cumulative test. The cumulative test has 3 parts. You might want to write these down because you might want to look back at Skyward and see which of these tests you didn't do so well on. There's a lot of you that got A's and B's, in which case I wouldn't redo anything. You still have to take the test, of course, but I wouldn't sign the little box as a retake if you got A's and B's. Now, it's very risky to retake a B. You know why? If you have a B right now, you have an 85%. There is no such thing on the cumulative test. There's either a 95% or an 80%. So the point is, you're very likely to have not gotten the A, and therefore it's risky to retake a B. And the other reason is, you know what? If you were a B last time, and now it's been a month since we took it, you really think you're going to be for sure at an A level? That's tough to do. So my point is, I would retake things lower than B's, like C's, D's. That's definitely probably something worth retaking. All right, to qualify for a retake, you have to have done your corrections. All right, I'm going to give you an opportunity because we have more time today and tomorrow that if you look up and you look in Skyward and you go, ooh, I did bad on that one, and I don't know if I did the corrections or not, you can ask me to see them and you can do corrections today and tomorrow. Okay, but not right now. Of course, we're going to do some practice problems first. All right, so if you would write these down, here are the top 3 topics. Graphing number 4, that's the one you just took yesterday. Properties number 2, and communication number 4. Okay, so I'm going to do a little review of everything today, and then tomorrow I'll be able to do a little review of everything again. All right, and the thing I'm not going to focus on very much is the graphing one because you just took that test. And I might do more of that tomorrow after you've had a chance to process your scores, which I'll give you later on that graphing test. So we're probably going to focus more on these 2 right now, communications 4 and properties number 2. And you probably are like clueless on what was on those, and I don't blame you. It's been a while. So for your communications test, that was more about, this is all about trig, right? So I'm hoping if I give you a point, like for instance, if I'm going to give you sine of some angle is √3/2, you should be able to figure out, I'm going to actually give you a little more info. I'm going to make it negative, and I'm going to say tangent is also negative. That narrows it down to where this has to be on the circle. You know, like, is it over here? Is it down here? Is it over there? You figure out where the triangle is. You label the triangle with all of its sides, and then you figure out for me what's, we already know sine of the angle. What is cosine of that angle? What is tangent of that angle? And then what are the flippin' sisters? CSC of the angle, that's the flippin' sister of sine. SEC of the angle, and COT of the angle. All right, go figure out where this is. If you've got a triangle and you know all the sides of it, including the negative sides, be careful with that, then it's easy peasy to figure out the cosine of that angle. You're going to be needing to use a reference angle too. All right, I'm going to give you a minute to figure out where this is, draw the triangle, label the sides, and figure out all 6, actually there's 5, because we already know this one. That's one of the 6. Find the other 5 out of the 6 functions. Okay, I'll be back in just a second. To start with, I hope you thought about all students take calc. How many of you have those 4 letters on your page? Awesome. That's a good start. Now, where is sine negative? Not here. Sine's positive there, and sine's also positive here. So I'm out of those 2. Next thing, tangent is negative. That's telling me something. It can't be here. Now I know I'm right here. Next thing is, I'm drawing the triangle even without looking at the angles. That doesn't really matter. I just draw the triangle in the reference position like that. Now, that's the important angle. And from that angle's perspective, the opposite is this, and the hypotenuse is that. The opposite is negative √3, and the hypotenuse is 2. Is that all possible? Yeah, the negative side's in the right spot and everything, so we're good. And then it should be a 1 over here. Now you've got to know these triangles well enough to know that the side across from the 1 is the 30-degree angle. That's a 30, so that makes this a what? A 60. But you shouldn't have left your answer as 60 degrees because that's not what I asked. Do you get, I didn't ask for the angle. I asked for the cosine of that angle, the tangent of that angle, the cotangent of that angle, the secant, the cosecant. You got to look at what the question is. The question could have been, what angle is that? And by the way, even if I had asked that, the answer wouldn't have been 60 degrees. It would have been all the way around to here, like that. And that's 360 almost, except you subtract off 60 and be 300 degrees. And if I was going to do it in radians, 60 degrees is pi over 3, and this would be 1 pi over 3. This would be 1 pi over 3, 2 pi over 3, 3 pi over 3, 4 pi over 3. That'd be 5 pi over 3. But again, that's not what I asked you. What I asked you was for cosine, tangent, etc. Yes, sir?
So would you not say sine of 5 pi over 3 equals negative?
It is 5 pi over 3. You're right, but that's not what I asked for.
You don't need it.
You don't need it. All you need is, what is cosine of that angle? Cosine of this angle is ca, adjacent over hypotenuse. 1 over 2. Cosine, you should have had 1/2. Raise your hand if you had 1/2. All right. More of you had it right than we're confident about it, at least. That's good. Tangent. Tangent's TOA. Opposite over adjacent. Opposite is negative root 3 over adjacent is 1. Negative root 3 over 1. And then, of course, the flipping sisters are just flip it over. So this becomes 2 over 1. This becomes 1 over negative root 3. Does it matter where the negative is? No, as long as there's a negative in it. And then cosecant is the flipping sister of this one. So I'm just going to take this here and flip it and make it 2 over root 3 and throw a negative on it. To make the point, I'm going to put the negative on the top. It doesn't matter where. Those are your 5 other functions. Yes?
So being for tangent, if we just write negative root 3, or if you like, no, we got the 1 for, like, something that's
It's fine if you write negative root 3. And over 1 is also okay, but it's actually best to simplify your answers. So yes, this one does simplify to negative root 3, and that's good. It's not a problem. All right, that's a kind of question. Now let's talk about another kind of question. Let's say that it's not one that you know the sides on. Like, that one we knew was a 36 united triangle. That was all hunky-dory. But what if it's not? What if I say sine of the angle is opposite over hypotenuse, right? What if it's 1 over 8? Is that even possible? Yeah, it is. It's not a normal, common right triangle, but it's possible. And then let's say the tangent is less than 0 again. Tangent's negative again. Now this time, I'd like to just know one of them just to save us time. What would be the cosine of that angle? I'll give you a hint. You're going to have to find the third side in your right triangle by using a Pythagorean theorem or just knowing that pattern. You'll find that third side's got square root in it. Okay. Here's what I was looking for on this one. If sine is 1 over 8, I know it's either here, all of them are positive here, or sine is positive there. ASTC. And then if tangent's negative, I can't be here anymore. Okay, sine was either, it can't be here and it can't be here if sine's positive. And then it can't be there because tangent's negative. So then I know I must be over here. How many of you were drawing your triangle in the right spot? Okay, good. If opposite is 1 and hypotenuse is 8, is that humanly possible? Sure it is. It's just not a common right triangle. What's the other side got to be then? I always have suggested you make the square root of, and then you just got to go 8 squared and 1 squared, and you got to figure out whether you should add them or subtract them. Okay. 8 squared is 64, 1 squared is 1. So 64 and 1, should I add them or subtract them? Subtract them. So it'd be why? Because this is the biggest side. So you take the biggest side minus one of the other sides. So it'd be 64 minus 1 is 65, root 65. There we go. Now can you simplify that further? Uh-oh, 64 minus 1 63, sorry. Okay, 63. Okay, so can you make 9 times 7 is 63? Ah, it can be simplified further, can it? Isn't it? 9 times 7 is 63. So then this is really root 9 and root 3. Root 7, thank you. And then this becomes 3 root 7. Did anybody have 3 root 7? Awesome. Would I make it wrong for that? Yeah. You have to have them simplified all the way. Okay, so now what's cosine of my angle? This is the angle. Cosine of that angle. And remember, this is called a reference triangle because everybody would really like to do triangles over there, but we can't a lot of times. So the angle in question would have been this angle, and this is the reference triangle we're using. Anyway, this is the central angle that we use for our reference angle. Cosine of that angle is adjacent over hypotenuse. This is the adjacent. This is the hypotenuse. Should have said 3 root 7 over 8. Oh, I think you got me again. This is going this way. It is negative. I agree. Negative 3 root 7 over 8. Did anybody catch that? All right, 6 of you beat the teacher on that one. Nice work. I'm very human, and I'm making these up as I go, so it's not, you're seeing real what would happen to me on a test. I would have been one of those kids that would have often got a B on the test because I would have made 2 stupid mistakes in the R3. All right. And one of the things, though, when you see a person doing it up here, I don't have a chance to check my work over before I turn in my test, so to speak. If I make a mistake, you guys see it right away, and I haven't had a chance sometimes to go back and look at it and make sure it makes sense. But that kind of brings up a good point. At the end, since you only have 4 questions in each section, you know how these work, right? There's only 4 problems for properties. You only have 4 problems to check over. Watch for negatives. Watch for things that are impossible. You know what I mean? Like we oftentimes, I'm not saying there's this on this test. I never tell you what's on the test, but we have often had extraneous answers, things that when you actually try it, it doesn't really work. We've had things where you have undefined, you know, like we're trying to find tangent, but it ends up being something over 0, and therefore it doesn't work. All right. I'd like you to find cotangent of pi over 6. That brings up those sister functions, and do you know how to handle it when I give you a sister function? Because if I had just said sine of pi over 6, that should have been laughably easy. But when it's one of these sister functions, we'll see if you know what to do. I'll pause for a second while you try that one. Got it? So let's see how you did. First of all, what if I don't want to do cotangent of pi over 6? Can I change it? I can. And this is like doing a sister function of pi over 6, except you got to flip it. So instead of cotangent of pi over 6, what could I do that I'd be more familiar with? Tangent. I could do tangent of pi over 6, and then just make sure that I have this 1 over there so that I remember to flip it at the end. Okay? So what if I change the problem to tangent of pi over 6? Well, to me, that's easier. So I'm going to draw my picture. Tangent of pi over 6. Pi over 6, I happen to have that one memorized. It's like 30 degrees, right? So if this is 30 degrees, you should be able to set up your triangle. And the one across from the 30 is a 1, and this is a 2, and this is the square root of 3. You with me so far? Okay, now, should I just do this and get the answer? I got to do it, get the answer, and then flip it. Okay, so tangent of this, tangent is TOA, opposite over adjacent, which should be 1 over square root of 3. And now, flip it. So therefore, square root of 3 over 1 is my final answer. Now, is there another way? Absolutely. If you want to memorize that cotangent is kind of like tangent except flipped, then you could say to yourself, well, I need to have Chosha Cow, C-A-O, okay, and this is just like tangent is opposite over adjacent. It's adjacent over opposite. I know this has got to be my adjacent side, this has got to be my opposite side. And then I draw a triangle that's got a 30 in it, because that's what this is, 30 degree. And then I go, once I got my triangle with a 30 in it, which everybody knows how to draw, I hope, then I do my adjacent side needs to be a root 3, and my opposite side would be a 1. And therefore it's root 3 over 1, which is root 3. Either way, it's root 3. Raise your hand if you had that one right. Okay, good. that's enough, I think, in talking about the communication kind. Let's talk about the properties kind. That's more about, it's a little bit like graphing, except you don't have to actually graph it. So what if I gave you one like this, -2 sine of 3x minus, no, let's make it 2x. 2x minus pi over 4 plus 1. And I could ask you a whole bunch of questions about it. I could ask you for the amplitude, the phase shift, PHASE. I could ask you for the period. I could ask you, I was going to say the B term, but I don't think we'd actually ask you for the B term. We'd probably just make you use the B term when you're figuring out the period. And let me see if there's any other kind of things that you'd have to know. Yeah, domain is another possibility, and range is another possibility. See if you can answer all of those questions about this one. Remember, if you need the phase shift, you have to factor on the inside there if there's a B term. Since I do have a B term here, you need to factor to get your phase shift. I'll pause for a second. Let me try that. Okay, so here's amplitude. If you put -2, I would cry a little bit, mark it wrong, and it's a Marzano style test, so it's over. Get what I'm saying? You got to be careful, really careful. Amplitudes can't be negative. There's no such thing. Amplitude is how high is the wave. You can't have a negative height of the wave. And remember that also, it's not judging the total height from the lowest to the highest. It's half of that, right? Okay, so anyway, it's really simple if you just are given the equation. You take the absolute value of that number, so it's 2. Raise your hand if you had +2. Good. The next one's phase shift. You got to factor that 2 out, and I know that's tricky. You take this, and this part's easy, x and minus, duh. But what number goes here? What I would do is remember that you're dividing both of these by 2, which is the same as multiplying it by 1/2. That's a hint on how to find it. This should have been pi over 8. How do I know if I'm right? You multiply it back out, and you can just keep guessing and checking if you have to until you find it. 2x makes the 2x. 2 times pi over 8 is 2 pi over 8, which does reduce to pi over 4. Okay? There, I got that factored. Why did I care? Because now that's the phase shift, and you say right. You don't say negative. You say right pi over 8. How many had right pi over 8 for that one? Okay, good. Next one is the period. Well, period is 2 pi over b. That's a really handy formula to know. We used it on our last test a lot too. So 2 pi over b. Well, 2 pi over, what's b in this case? 2. Don't overthink it. That's the b right there. So 2 pi over 2, the 2's cancel, and your period must be pi. We had that part right. Okay, that's a bunch of people had it wrong. I'm surprised. Either that or you're doing something else. Stay with me, please. The d is the domain, and sine goes forever in both directions, and therefore all reals. That is an okay answer, or even better, negative infinity to positive infinity. We do like those, brackets and parentheses for, what's that called again? Something notation. Interval notation. Okay, and then the range. Well, that's really how low to how high. This one's a tricky one. Do you get that if I changed my numbers here, it'd be +2 and -2, but it's not quite that simple? This 2 does affect it, but it also has been moved +1, up 1. So it doesn't go as low as -2 anymore. See what I mean? It's been moved up a notch here and up a notch here. So it would be from -1 to +3. That was a nasty one. How many have caught that twist? Good. More than half. Okay. Any questions on those? All right. This test was also the one where we covered how you can get multiple answers to a question. You know what I mean? Like you can say, here's a problem and there's more than one answer. Sometimes there's 2, It is possible to only have one answer, but the answers are between 0, and it can be 0, and 2 pi, and notice it cannot be 2 pi. There's no or equal to. Remember this kind? Where you get 2 answers for it? All right, try to find this one for me. If cosine of the angle is negative root 3 over 2. There's 2 places that happens, and they are not small angles. If your answers are like pi over 6 or pi over 4, you're doing something wrong, because cosine's negative means you can't be here. So figure out where else you can't be, or where else you could be, I guess you'd say, and draw a couple triangles and figure out your answers. I'll pause for a second while you give this one a shot. All right, so let's see if you know where to go here. I'm hoping you know that cosine is negative. All students take calc there and there, because cosine's positive there. Okay, so then I must be over here. I'm going to draw myself a nice triangle. There's a triangle here. And once I know that triangle, the other triangle would just kind of follow automatically. This triangle, I have to be careful now with my sides. Cosine's adjacent is negative root 3, and hypotenuse is 2, and I made the correct one negative. The hypotenuse can't be negative. And then it's the 1, 2, root 3 triangle. It's across from the 1 again. And here's a really common mistake. People say, so my answer's 30. Or even closer, at least it's in radians, my answer's pi over 6. But it's not pi over 6. It's all the way to here, which is 5 pi over 6s. 5 pi over 6 is one of your answers. Raise your hand if you had that one right. Good. And then the other answer is, you don't have to reinvent the wheel here. This triangle right here is going to have a 30 or a pi over 6 in it right there. But I'd say this is 6 pi over 6 plus one more gets me 7 pi over 6. Those are my 2 answers to that question. Raise your hand if you had that one right. Good. More people had that right than I would have expected. All right. That's not everything, but that's enough review for today on those topics. Now, let's get you your graphing test back. For those that haven't taken it yet, raise your hand. All right, you 3, you need to head in the hallway. Please be at least 10 feet away from the door. And that's all I have for the video for today. We'll talk more about graphing, on tomorrow's review day.